Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alright, let's take a look at our homework for lesson 3.2.2. Our M&Ms are covering circle vocabulary. Not quite sure why this is fitting in right now, but I guess why not? Okay, so here we have a circle, which is a collection of points that are all the same distance away from a center point. The distance from the center point to the edge of the circle is called the radius. If you have a line segment with endpoints on the circle, that's called a chord. So a radius is not a chord because it only has one endpoint on the circle. The other endpoint is on the center point. Diameter is a special kind of chord. It's actually the longest chord that you can fit on a circle because it passes straight through the center of the circle at its widest point. So you can see this chord is not as wide as or as long as it could be, but the chord that passes through the center point is the longest one possible, and that is a diameter. So the diameter is a chord that passes through the center point. It's also made up of two radii. So the radius is half of a diameter, and the diameter is equivalent to 2 radii. With that being the case, we start looking at some different formulas. You've got a formula for circumference, which says when you multiply the diameter times pi, you're going to get the distance around that circle. So the circumference is the measure of the distance all the way around the circle. If you were to take and put, say this was a piece of string, and you were to cut it and lay it out against a ruler, the total length of this line, once straightened out, is the circumference. Now, pi itself has a value, which is an irrational number, which we call 3.141592, but usually we round that off to 3.14. Now, you have a calculator that allows you to do this work for you. There's the pi button right there. So back in the old days, we would always round pi off to 3.14, then multiply it times the diameter. But in a situation like this, what are we saying is our diameter? I guess they don't tell us what the diameter is. Let's just pretend the diameter is 5 inches. So we would take 5 times pi, and instead of punching in 3.14, you hit the pi button, and it gives you like 20 decimal digits of pi. So this is going to give you the absolute most accurate answer for pi, but we're still going to round it off to either 15.7 or 15.71. Now, let's see what we would get if I were to multiply 5 times 3.14. 15.7. So it ends up being almost the same, like within 100th or 8 thousandths. I don't know what I'm trying to say. It's very, very close. So you could go either way, but the bigger the number is for your diameter or radius, the more accurate it's, or the less accurate it's going to be if you round pi off to 3.14. So I like to have students use their scientific calculator and use the pi button for pi every single time, and you will get the most exact answer you can possibly get. Then we have area. And area has an interesting formula. It's pi r squared. So you can take whatever the radius is, square it, multiply times itself, and then multiply times pi, and you'll figure out how many total square inches are on the inside there, or whatever the unit of measurement is, square units. All right, on graph paper, draw figure 0 and figure 4. So figures 1, 2, and 3 are already provided. So let's do some analysis here and figure out what we've got. Figure 1 has 4. Figure 2 has 1, 2, 3, 4, 5, 6. Figure 3 has 1, 2, 3, 4, 5, 6, 7, 8. So it looks like it's going up by 2 every single time. And it looks as if these are where the 2 are added on every single time. So for figure 4, oh, what happened there? Why did that get cut off? Well, let me just go ahead and fix this. Figure 4 should have looked like that. 1, 2, 3, 4, 5, because we added one more to this. And 1, 2, 3, 4, 5, 6, 1, 2, yes, that one was on there. So this should have 10, right? Because it's 2 more than 8. 5, 6, 7, 8, 9, 10. Yes, that's correct. And the 0 should have taken this guy and this guy off, so it would have looked like this. Should have had 3. No, it shouldn't have had 3. What should it have had? Should have had 2, because we took the 1 off from the top. So yes, there they are. These 2 right there are those right there. So figure 0 has 2, figure 1 has 4, figure 2 has 6, figure 3 has 8, figure 4 has 10, and then that would keep going on and on and on and on and on. So when we plot those points on a graph, notice I didn't connect the dots this time. That's a discrete graph because we're not dealing with any figures in between the 0, the 1, the 2, the 3, and the 4. The growth rate is growing by 2 every single time, and the starting point was at 2. So, just think about our silent board game. What do you multiply times 1? You multiply 2 times it, so that's 2 plus 2 is 4. 2 times 2 is 4 plus 2 is 6. 3 times 2 is 6 plus 2 is 8, and so on and so forth. So that is absolutely the rule that applies to this situation. Then what's the last question? Without drawing figure 5, predict where its points would lie on the graph. Well, the points are going to lie on this straight line, right? So it would be 2 units up and 1 unit to the right. It would be right around there at 512. Examine the graph at the right. Use the graph to complete the table. All right, so we're looking at the graph, and the graph has been properly scaled. And while they didn't number every one of those tick marks, we know they're counting by ones, right? Because we know this is 0, 1, 2, 3, 4, 5, and so on and so forth. So if we know the points and we can identify where they line up on the X and the Y axis, and this is not very perfect. It's supposed to be up a little bit higher, but whatever. I hope they didn't want me to write that in as decimal numbers, because how are you supposed to know? I don't know. Let's just go ahead and say that this is 2, 3, that's 3, 5, that's 1, 1, this is 0, -1, that's -1, -3. So we plug those numbers in, and now we play silent board game again. What do you do here? Is it adding 1? No, because you didn't add 1 to this. So let's double it. 4, and then we'd have to take away 1. Here you double that, 6, and then you'd have to take away 1. Here you double that, that would be 2, and then you take away 1 to get that. So it turns out the rule is y is equal to 2x minus 1. Find the area and circumference of the circle with a diameter of 15 centimeters. All right, so this is what we were talking about with our M&Ms today. So draw a circle. The diameter is 15 centimeters, which means that each one of the radii would be 7.5 centimeters. So for the circumference, you multiply pi times the diameter. So pi times 15 is going to end up rounding off to about 47.1. So notice how I did do the rounded off version. Had I done the pi button, 15 times pi would have been, come on, stop it. 15 times pi equals 47. It still rounds down to 47.1, so that ends up working out just fine. And now for the area. This gets a little trickier, and I would recommend that you always use calculators here, because squaring decimal numbers isn't a lot of fun. So 56.25 is radius squared. Let's check that out. 7.5. You can either hit a button there that says to square it if you have that on your scientific calculator. Better make sure I do that 0.5. Or you can just do 7.5 times 7.5, because why are you not doing it 5? There you go. Because when you square a number, you multiply it times itself. So there's your 56.25. Now multiply that times pi. And you get 176. All right, so here you go. This one, it's a little bit more. So I would round this off to 176.6. This says 176.7 once rounded off. So, by rounding off pi, you affect the answer. It gets a little bit lower than what the real answer is. And the bigger the number is that you're multiplying times pi, the more of a discrepancy you will see. So it's totally okay to use 3.14, but if you want the most accurate answer, use the pi button on a scientific calculator. And simplify each of the following equations and solve for the variable. All right, so 3x minus 7 plus 9 minus 2x, that simplifies down to, what is it? 3x and -2x gives you 1x, and then -7 plus 9 gives you 2. So x plus 2 is equal to x plus 2. Well, they're the same expression, which means any number you plug in is going to work. So there are an infinite number of solutions that would work there. In each one of these cases, you combine like terms, and then you start going through the process. So here, this would be negative m plus 9 is equal to 0. So I will take away 9 from each side and get the opposite of m is equal to negative 9, which means that m has to be equal to 9. I think this one's pretty straightforward, but D, I seem to recall in the past students struggling with problem D. So this is what I would do. There is this process. Now, maybe I better not show that. Maybe we just do it the traditional way. So if I take 0.5p is equal to p plus 5, then I would probably subtract p from each side since you've got the 5 over here. But we need to understand that you are taking 1 away from 1/2. So 0.5 minus 1, let's use the calculator. 0.5 minus 1 gives you an answer of negative 0.5. So this has to be negative 0.5p is equal to 5. Now, what number do you multiply times negative 0.5 to give you 5 for an answer? Well, I'm not sure, so let's go ahead and do the division. And a positive divided by a negative is going to give me a negative answer, and now I have to figure out what is 5 divided by 0.5. It is 10. Since we knew it was going to be a negative answer, we're going to say p is equal to negative 10. Now, it's always a good idea to check, right? Check your solutions. So what is half of 10, or half of negative 10? Would be negative 5, should be equal to negative 10 plus 5. And sure enough, negative 10 plus 5 is equal to negative 5. So that checks out. Our solution is correct. Mr. Wallace has done it again. He has started to create more tables to help him figure out things like how many gallons of gas it takes to travel a certain number of miles or how many minutes it takes to walk a certain number of blocks. Use proportional reasoning to complete his tables. Now, I guess the question is, why are we using proportional reasoning here? Well, I would say here, if you don't spend any time reading, you're not going to read any books. And if you don't read any books, it's not going to take you any days. So 0, 0 applies, and we're expecting it to be like an average number of books per day or days per book read. So there would be like that constant unit rate. If you spend no time walking, you're not going to go anywhere. So 0, 0 applies here. And if you spend no time driving your car, you're not going to use up any gas. So 0, 0 applies to all these situations. And we're going to assume a constant or average growth rate for our straight line. So how do we figure out what the unit rates are? The unit rate here is 1 book every 5 days or 5 days per book. How do we get that? 10 divided by 2 is 5. 50 divided by 10 is 5. And once you know the unit rate, then you can figure out all the others. 60 divided by 5 is 12. 3 times 5 is 15, and so on and so forth. Here, our unit rate is 2.5 blocks per minute. How do you get that? 25 divided by 10 is 2.5. So once you know that every minute he walks 2.5 blocks, then you can figure out the rest of these. And miles per gallon, I guess, notice how I switched them around. It seems like the miles should be the Y and the gallons be the X. You may have switched them and gone in the other direction, so you might end up having the number of gallons per mile, which would have been something like this: 14 divided by 280. If you had 5/100ths of a gallon per mile, that would be acceptable too, because honestly, they don't tell you which direction you're supposed to go in here. I always think of it as miles per gallon. That's why I made X my gallon, and that's why it would be 20. And by the way, 0.05 is the same as 1/20th, which happens to be the reciprocal of 20. So by changing the order, your multiplier ends up being the reciprocal. Just a little side note. And so here is an example of that unit rate. 20 miles per gallon. So 14 times 20 is 280. 7 times 20 is 140, and so on and so forth. And that does it for today. All right, so let's get moving on to our lesson for today.
Hey, feeling good.